We're in 5.4 still, and what we're going to do here in problem number 11 is toss a coin 6 times and observe the sequence of heads or tails, and we want to know how many different sequences are possible. So we're going to toss this coin 6 times. So we've got a first, second, third toss, fourth, fifth, and sixth toss. Let's look at each toss here and see how many ways we can do it. So here's the first toss. How many choices do we have here? Well, it's a heads or a tails, so there's two possible results here. 2 here for the second, 2 for the third, 2, 2, and 2. If we multiply these together, we're looking at 2 to the 6th, which is 64 possible sequences of heads and tails. Now, problem number 12 is almost the same as problem number 11, except here's what happens in this one. What we want to know is how many ways can we toss these. How many sequences can we get? 1, 2, 3, 4, 5, 6. If when we toss the coins, the first and the last results are the same. So let's count these. So there's still 2 possibilities for the first toss, right, heads or tails, and then 2 for the second, 2 for the third, 2 for the fourth, 2 for the fifth. But now, this toss right here, we're not free to choose that. This one here, by the restriction in the problem, has to match this one. So how many choices do we have? Well, we don't have 2. If this one's a head, this has to be a head. If this is a tail, this has to be a tail. So we don't have 2 choices. What we do have, though, is just 1 choice. Make sense? So what we're going to get here is 2 to the 5th, so we'll have 32 of these possible sequences. Now, problem number 16 is an outfit problem again, just like number 2. But this time what we have, what do we have? We have 2 coats from which to choose, 3 hats, and 2 scarves. So here's our decisions. Which coat should we wear, which hat, and which scarf? So we have 2 ways to make the decision for coats, 3 hats to choose from, and 2 scarves from which to choose. So we're going to have altogether, that looks like 12 different outfits we can make. Now, problem number 20 says a company has 700 employees. So let's note that. There are 700 employees in this company. And what we want to do is explain why there must be 2 people that have the same pair of initials. Now, it does say same pair of initials. So we're going to have a first initial and a second initial. And somehow we want to be able to show that out of these 700 people, at least 2 of them have the same pair of initials. Well, maybe we could think of it this way. If we lined everybody up and started handing out initials, the very first person could have any one of 26 initials for the first name and 26 for the last name. So if we did that for every person, there are 676 possible pairs of initials. But what do we do then with person number 677? So person 677 is going to have one of these already assigned initials, right? These are all the initials that we have, and then person 677 is going to have to repeat somehow. All right, so what we're going to have actually then is 700 minus 676 is, let's take it, 700 minus 676. We're going to have 24 people that are going to have some repetition of initials. Now, problem number 26 says this. We have a 2-circle Venn diagram. How many different shadings could we get? So let's get an idea here. Here's one possible shading. We could shade this region right here, right? That's one possible shading. Here's yet another possible shading. We could shade the area that we just did. We could shade that region, as well as maybe we could shade this region out here. So here's 2 possible shadings. So the problem asks us, how many possible shadings can we get? Here's how I'm going to count these. I'm just going to do this by pointing. So if I point out here in this region here, I could either shade or not shade. So I have 2 choices for that region. Then if I come in here, I could shade or not shade. So again, I have 2 choices for that region. And then here, in this intersection, I could shade or not shade. So once again, 2 choices here. And then finally, in this region right over here, we have 2 choices, shade or not shade. So We'll have 2 choices there. So altogether, we'll get 2 to the 4th, 16 possible shadings for that 2-circle Venn diagram. Now, problem number 28 says that a club can elect a member as a president and a different member as treasurer. So let's see what we've got so far. We could have a president and then a vice president, but then it goes on to tell us that they don't tell us how many members we have or ask that. All in all, we can make these selections, president and vice president, we can make those selections in 506 ways. So this is a little bit backwards in the sense that instead of given these numbers and producing this number, we're given the result and asked to go backwards and get these numbers. So we don't know how many people are in this group right here. So since it's unknown, why don't we represent that with maybe n? So if there's n people in the group, we have n choices for president, and then take the president out for the vice president because they have to be distinct, so there's 1 less. So how about n minus 1? So we have n choices for the president, n people in the group from which to choose, and then 1 less for the vice president. And by the multiplication principle, if we multiply these together, n times n minus 1, we're going to get 506. So how's your algebra now? Let's multiply these together. We'll distribute. We'll get n squared minus n equals 506. Subtract 506 from both sides. We'll get n squared minus n minus 506 equals 0. This is quadratic, so we're going to factor. So we'll set the 2 parentheses, anticipating we can do this. Don't forget to equal 0. And we can start here with n and n. You know, this is a little bit tricky here because this 506, that's a bigger number than we've typically seen in our algebra courses. So what I'm going to do is I'm just going to list all the factors of 506. So we can get 506, we can get 1, it's even, so 2 will divide it, and with my calculator I can see 11 divides it, 22 divides it, 23 divides into it, 46 goes into it, 253 goes into it. So it looks to me like I'm going to start here with this pair because 22 and 23, they differ by 1, right? That's what I'm looking for. So let's see. Now, n cannot be negative, so we can cross that one out. So here's what we'll get. N is equal to 23. So how many people are in this organization? We will conclude there's 23 people.